Hello students, hope you are doing well. So today we will discuss the practical implementation of function overloading. Okay, so we'll just see that how to create a program and how to analyze the concept that we have discussed in yesterday's class. So I'll just create a small program that demonstrates function overloading concept. So I am just creating a function, okay, double add, and I'm just passing some parameters int a and double b. Okay, so here it is. So I'll just write some message inside this so that, okay, when we'll just compile this particular code, so we'll be able to get that which function is calling. Okay, so I'll just write first function executed. Okay, so I'll just write first function executed and we'll give a new line and we'll just return. Okay, so we'll just return a plus b. So this is a small function we have created. So again we'll create a function. Okay, so let it be float. The name of the function is add. Okay, so here you must remember that in function overloading the name of the function is the same. Okay, how many functions we are creating, it doesn't matter, but the name of the function must be same, and it should follow certain rules like the return type of the functions, sorry, the return type of the parameters that I'm passing. Okay, it should be different. Okay, it should not be same, else it will result in an error. The order must be different, and the third is the number of parameters we are passing. Okay, so just pass a parameter float a and int b. So again I'll just write cout second function executed, and we'll just put a new line. So I have just created the definitions, okay, for these two functions. The functions are having same name but different return types. So I have created the two functions here, okay, having similar name but return types are different and the order is different here. Okay, and here we have only, okay, the third case is not valid here because we have only taken two parameters in both the functions. We can also create a function that contains 3, 4 and 5 parameters. Okay, we'll see. First we'll just see the concept. So I'll just create a main, and inside this I'll just write cout because I have to call the function also. So I'll just write add and I'll write 10 comma 20.5. okay, this is first, and I'll just give a new line here. Okay, cout handle, and I'll just write add and I'll just pass 10.5 f for example and 20. Okay, so this 10.5 f is for the float data type. Okay, and this 20.5 resembles to double. So now if I try to execute this code, okay, if I try to execute this code, so let's see what happens. So here is a warning. Okay, what we have done, we haven't returned anything. Okay, so it's given a warning that return a plus b. Okay, so this is a blunder we have done here. So now it will be, I think, successfully executed, compiled, and let's try. Okay, let's try to judge that what should be the output. Okay, so for the first function, okay, as we know that in function overloading it is completely based on the compiler's, okay, judgment. So the compiler will judge the function, okay, on the basis of the call must be judged on the basis of the type of the parameters that we have passed here. So for the first function, okay, for this first call, that is 10 comma 20.5 we have passed, it will match. Okay, so 10 and 20.5. okay, 10, the first parameter is matching. Okay, so it will go, okay, with the second parameter itself. So the second parameter is also of type double and it is also matching. Okay, so the first function will be executed. Okay, because it is a perfect match. Okay, a perfect match is there. Okay, this is an example of a perfect match, okay, in which both the parameters are perfectly matching. Okay, similarly in the second case it is 10.5f and 20. So the first parameter, okay, if it will check, okay, both the functions, it is the compiler's task, and it found that this 10.5f is matching with the second function's first parameter, and similarly this 20 is mapping with the second function's, okay, second parameter, and it is also a perfect, it is also a perfect match for the compiler. So there is no ambiguity and there is no confusion for the compiler in mapping both the functions, and both the functions are perfectly mapped and matched by the compiler, and as a result of which we will expect an output that first function executed and it is 30.5, and similarly second function executed and it is 30.5. So let's try to analyze the output here. So here you will see the output that first function executed 30.5 and second function executed 30.5. So there is no, you can say there is no ambiguity. Okay, it is a perfect match, it is a direct match. Okay, based on the type of the parameters that we have passed in the calling, it is matching with the compiler is matching that parameters at the definition, functions definition. So now let's try to change. Okay, let's try to change the parameters and let's try to change, let us suppose the function here. Okay, the definition let's try to change. So if I just write this as, let us suppose, a double, okay, this is a double a for example, and for example the second parameter is int b. Okay, you can give it any, okay, data type, it is up to you, and okay, this will be same. Okay, we don't, okay, change the contents of the definition because we have to see the output as it is. Let's change the second function also. Okay, so let's try to give it a name, that is, let us say the return type is also double. Okay, as the function overloading doesn't depends upon the return type of the function. Okay, and let's try to pass a variable, let us suppose this is int a and this is, let us suppose it is float b. Okay, this is float b. Okay, so now what we'll do, we'll just write 10.5, so just change it to 10.5, and let's change this to, let us suppose this is 20 comma 10.5. So now let's try to compile this. Okay, and let's see what we have done. Okay, so it has been successfully compiled. Now how the compiler will, okay, map again for the first function. Okay, you will see the first function, the first parameter is 10.5 and the second parameter is also 20.5. So the compiler will check, okay, both the functions. Okay, there, if there are n number of functions, then for this function definition, for this call, the compiler has to check, okay, for what type, okay, for what type the function call must be mapped with the definition part. So here the first parameter is double, and in the first, okay, in the first definition the first parameter is also double. So, and it will also check that in the next, okay, in the next, you can say, function, the first parameter is int and it is not mapping with this particular, okay, data type or this particular value. So the compiler will just ignore this, okay, because it is not mapping. And here you can also see that the second function is also not mapping because this is 20.5, this is double, and this is float. Okay, so the compiler will, okay, ignore this particular part because it depends, it checks on the basis of the type that we have passed. So this will be mapped double 10.5, it will be passed here. And now for this, you can see for this particular parameter, for this value 20.5, here it is int and here it is 20.5. So the compiler will do implicit conversions now. Okay, so as we have discussed in the earlier lectures that there are two type of things, promotion and conversions. Promotion is in the same family and conversions are, okay, it is irrespective of any family. Okay, so this 20.5 double value will be, okay, converted to an integer value. It means narrowing will be done. Okay, narrowing will be done. It means 20.5 will be converted to 20. So this function add will be mapped. Okay, this add 10.5 and 20.5 will be mapped to the first function, and we will get an output that is 30.5. Okay, so this 0.5 will be truncated because now this value has become 20 because it has the compiler has implicitly converted this 20.5 to int. Okay, so now this is an example of, okay, so this is an example of best match. If any one value is mapping, if one parameter is mapping, then the compiler will, okay, try to convert the second parameter on the basis of either type, on the basis of either promotion, or you can say on the basis of standard convergence, okay, widening or narrowing, it can be any case. So for the second case, okay, so here we will expect, so we'll just write that we will expect, okay, we expect first function, okay, to be executed. We'll just check, but this is a dry run we are just doing, executed. Okay, and for the second function, okay, for the second function you will just see 20 and 10.5. so the first parameter is 20 and second is 10.5. so the compiler will check that for both the definition call, for both the definitions, okay, this call is being mapped to which definition. Okay, this is the responsibility of the compiler based on the type of the data that we have passed here. So first is 20. So in first case, okay, this is double, okay, it is not mapping, and the second is 10.5, so it is also not mapping. So compiler will ignore this. Now the compiler will check, okay, the second function. So this 20 is being mapped with this integer because it is also of type integer and this is also type integer, so it is perfectly mapping. Okay, the first parameter is perfectly mapping, so we can say that it is also a best case. But the second parameter is not mapping. Okay, this is 10.5, this is double, and this is float, so this is not mapping. So again the compiler will do implicit standard conversion, and this 10.5, that is this double value, will be converted into a floating point value. Okay, so this 10.5 will be converted to 10.5 f. Okay, so a narrowing will be done. So it is also an example of, you can say, a best match in which if one parameter is mapping, then the compiler will try to convert the other parameter depending upon the implicit convergence. Okay, so this is also a best match, and what we will expect, we'll expect second function. Okay, so we expect that second function must be executed. Okay, so now let's try to see. Okay, so the answer will be, okay, for the first, okay, the answer will be 30.5 for the first case and 30.5 for the second case. So it will be first function executed and 30.5. okay, first function executed 30.5 and second function executed 30.5. so let's try to compile this. So if we try to run this, so here you can see the output is first function executed 30.5 and second function executed 30.5. okay, so this is the example of a best match. So now coming to the third case where the ambiguity is there. Okay, so if I just, okay, in the same question, if I just want to change, if I try to, okay, make some ambiguity, so if I just write, let us say here also I just write 10. Okay, this is 10, and okay, so let's try to check. So here you can see this says that ambiguity int. Okay, so there is an ambiguity. Okay, so why there is an ambiguity? Because of this statement. Okay, this statement that we have written for this function, the compiler is throwing an ambiguous condition because for this function call, the compiler is unable to map this function call with the two function definitions. Okay, the compiler is not able that this 20 and 10, how to map this. Okay, so let's see 20 and 10. So you can see for the first function this is not mapping, but this 10 is mapping. This 10 is mapping for the, okay, for the first function. So we can say that it is a best match. Okay, but again, if the compiler is, okay, if the compiler tries to check, okay, that for the second function also, okay, the first parameter is mapping but the second parameter is not. Okay, so in this case the compiler is in a state of dilemma that to which function call should I go. Okay, should I go, okay, to this definition part, okay, or should I go to this definition part? Because in the first case the second parameter is int, okay, but first is not, okay, not mapping, it is not int. And in the second case, Okay, the first parameter is int, that is it is mapping with this, but the second is flu. So here the compiler can also do that. It can map this 10 can be mapped with this, and this 20 can be converted to 20.0f, sorry, 20.0, okay, to double. And it can also do, it can map this 20 to this int, okay, and this 10 can be, okay, 10 can be converted, or 10 can be, you can say a widening can be done, and it can be converted to 10.0f. But if this case is there, then the compiler is now confused that in both the cases, okay, which function I have to support, because in both the cases the compiler can do this type of task. So here it says that this condition is ambiguous, this overloading is ambiguous, because now I am not able to judge to which function should I go. Okay, for this function call, the compiler is in a state of confusion that this function calls should bind to which definition part, either it should go with first definition or it should go with second definition. What is this? This is an ambiguous, this is an ambiguous condition, you can say. Okay, so these are the three cases, okay, with the help of which we can determine that how the function overloading is being done, okay, with the help of a C++ program. So I hope now it is clear to you. If you are not clear, so please try to see the earlier lectures, okay, the first two parts of the function overloading concept, and then try to just come to this program and just try to, okay, map the concepts or try to correlate the concepts with these. Okay, so thanks.